Facebook Messenger is an instant messaging application available for many operating systems. As one of several embodiments of Facebook services, this app holds a plethora of information that might be valuable in forensic investigations. The application's SQLite database and cached data can be parsed in order to retrieve and create artifacts such as contacts, messages, and images. Moreover, the app's database can be queried for deleted records with external tools like Unduck. W10-Face Messenger at Autopsy is a data source ingest module that analyzes the data stored by the beta version of the Messenger app on Windows 10. To do so, it makes use of the standalone application W10-Face Messenger, available only for Windows 10.
The Autopsy speech-to-text module allows automatically detecting and transcribing files which contain speech. When adding a data source, the file type identification ingest module should be run. This is needed in order to identify all the audio and video files. This data source contains 2 text files, 1 audio file with speech,
big budgets, very slow,
and 2 audio files with music. The voice activity detection ingest module will find all audio and video files which contain speech, according to certain criteria. If the transcribe files with speech detected option is activated, the module will also automatically transcribe files with speech. The detection and transcription process can take a long time. After the ingest module has run, new items appear in the interesting items. Here, the only audio file with speech was correctly detected. The ingest module also detected that the speech was from a male. The transcribed text is added as a Blackboard artifact. It can be seen in the Results tab and in the Extracted Content section. The Speech-to-Text Report module generates HTML or CSV reports containing all the transcribed text. It is also possible to manually select which files are to be transcribed by adding the file tag transcribe. The transcription can then be executed using the Speech-to-Text Report module.
Hello, this is our entry to the Autopsy module development contest, which is Autopsy modules for Nintendo Switch. Who are we? We are a technical security consultancy called Modux, and we mainly conduct penetration testing. However, we also have fun and interesting areas of research that we look into, such as simulation and forensics research. One incarnation of this is a project we did for the Defence Science and Technology Laboratory, which is the UK equivalent of DARPA. And we looked at the Nintendo Switch. Why the Switch? Because it's very widely used and it's also portable. We developed 10 separate modules as part of a suite for analysis of an extracted device. We extracted data from the NAND flash memory using an exploit called the Deja Vu exploit that works against the NVIDIA Tegra processor. We then were able to see the contents of the NAND file system. The user and system partitions are the ones that we are interested in. There are several forensic artifacts that we found manually at first and then latterly automatically. Firstly, the device user accounts, which contain several items of personally identifiable information. We also found wireless SSIDs and passwords, connected devices, games that are played, YouTube searches, and other players that are played with, enabling us to develop a forensic timeline.
Hi, this is Mark McKinnon. I'm going to be demoing the plugins that I've written for the OSDFCon Autopsy Module Development Competition for 2020. This year I am submitting 7 plugins. The first plugin will be the SysDiagnose plugin. This plugin was created after attending last year's OSDFCon and going to the presentation using Apple bug reporting for forensic purposes by Heather and Matea. So what this plugin does is you run your SysDiagnosis and get your SysDiagnosis information, add it to a case as a logical file set, and then you can run this plugin. The plugin is named iOS SysDiagnosis. Once you run that, it will then create all the artifacts that it can actually find within your SysDiagnosis dataset. So here we can see app name with GUID IDs, We can see that there's some backup info in Wi-Fi networks. So that's what this plugin does. The next plugin I'll talk about is the Mass Export Extractor plugin. This plugin will extract files based on file extension and put them into the exported files directory. We can see here that we just have to give it a comma-separated list of file extensions that we actually want to extract. Once you have that list and then run that plugin, if you go to your case folder, export directory, you'll see a directory called Mass Export. From there, it will give you the different file types or file extensions that you wanted to export, and under each file extension it will show you the files. Now you'll notice that each file has a number in front of it. This is the ID that is generated from Autopsy, so this keeps it so that you have a unique PDF every time, or it'll be a unique file, whatever the file extension is that you use each time. So even if you have duplicate names, they won't be duplicates with this file ID on it. The next plugin I'm going to talk about is the Ring Central plugin. This plugin will parse the Ring Central files that are for conferencing. Here we can see the Ring Central meeting chats. Once you run this, it will then produce the chat messages based from the Ring Central. So here we can see we had a meeting date, a meeting ID, chat time it was sent, and who it was from, and what the message said. There's also a chat too in case there was a private, it looks like. So all that information is there. Next one we're going to talk about is the word list. The word list will generate a word list based on your keyword search. So when you have a data source, doesn't matter what it is, first you have to run your keyword search. Once you run your keyword search, then you can run your word list. Once you run that word list, this will run a while because it's going and getting all those keywords that you actually have and checking it out and writing them to a file. There might be a potential problem if you have a very, very large data source that it could run out of memory as it's creating this word list. But if you go to the tools and open case folder, under export, you can see the word list that was generated. We'll open this up in Notepad so that you can actually see it. So this will be all the words that it could actually find from your keyword search. It will also include file names and other things as well. Next, we're going to talk about Google Takeout. So if you have a Google Takeout, if you've gone to Google and done a Google Takeout, you may be presented with one or multiple files. So what you need to do is you need to add all the files from the takeout into a logical data set. From there, you run the Google Takeout plugin. And what this will do is it will create a new data source for you and put everything in the directory structure of how it would look from if you were to expand each of the Google Takeouts. So then you can start looking at different things within the Google Takeout. For example, here on Google Drive, we have files, so we can see what the files are from the Google Takeout. We also have photos and so on. So you can actually see all of that information and now you can start processing that information using other plugins if you'd like to. The next one we're going to talk about is the AD1 extractor. So if you have a AD1 file, bring it in as a logical data set and then run the AD1 extractor plugin. Here we have the AD1 extractor plugin here. And it will extract all the files from the AD1 and add it as a new data source. And it will add it with that directory structure that it actually had in there. You'll notice that the created time, modified time, and change time and access time is all zeros. It's because this does not get added back in. But it does create an extracted content view of this, and it will show you the name, the directory, and the date, modified, and access time, as well as the MD5 and the SHA-1 hash from that AD1 file. So all the information is there. You can now use this along with the extracted content, and you can run your other plugins against it if you would like to. The last one we're going to look at is our LevelDB. This plugin, when you run it against a data source, will look for all the LevelDBs that are in this data source, and it will extract the key value pairs from each of the LevelDB databases. You'll notice here that the source file says manifest with a LevelDB. The LevelDB is actually the whole directory with all the files in it. So it was easier to, instead of doing that, to put it to the manifest file, because that was what I had access to, and I can tell that's what a LevelDB is. And here we have our name, which is our key, and then we have our value. And then the path here is the path where the LevelDB actually resides. So you can go through all these and note that I'm just showing you the key and the value. I'm not trying to parse any information out within that key value. I'll leave that up to another plugin to do.